Okay, so this is my absolute favorite unit. I really enjoy trig proof, which is what we're going to be doing over the next couple of weeks. With trig proof, the one thing to understand is this is not the same as geometry proof. You're still using rules and identities and those kind of things, but you don't have to justify anything. As long as you can algebraically work it out and show all of your steps, you'll be just fine. So one thing I really want to point out here is that while you don't have to memorize the formulas, you'll be given formula sheets, it will become very beneficial to be comfortable with them. So you don't have to think about what do I have to use, okay? You simply use what you know. So the identities that we're going to talk about mostly today will be the quotient identities, okay, which says that tangent of t equals sine over cosine, and cotangent is cosine over sine. The reciprocal identities, which you know those, sine is 1 over cosecant, cosecant is 1 over sine, and so forth on those ones. The Pythagorean identities are new. It says that sine squared t plus cosine squared t equals 1. Okay? Note that if this is a minus sign, it does not work, and there is no way to make it work. All right? Tangent squared t is the same thing as secant squared t, and 1 plus cotangent squared t is the same thing as cosecant squared t. The rest of these are not as important. We won't use these as often. If you have them, though, just on the back burner if you need them for other things. The identity ones work quite easily because if we have a sine negative t, it's the same thing as sine t. Cosine of negative t is the same thing as cosine t. That's convenient. And then tangent's the same as sine. Tangent of t is the same thing as negative tangent of t. Realize that what we're doing is we're saying we can replace. So if we have sine squared t plus cosine squared t, we can always replace that with a 1. If we have a 1, we can replace it with sine squared t plus cosine squared t. So as we go through the examples today, I'm going to be doing a lot of replacing. So moving on, example 1, tangent of t times cotangent of t. And we want to simplify it as much as we can. So we know that cotangent is 1 over tangent t, so we can replace that. That equals tangent of t over tangent of t, which equals 1. So that's kind of our goal when we're doing these, is to simplify as far down as we can. So we replace things with other pieces so that we can put it together as simply as possible. This is practice problem number 1. Just a hint, tangent of t is the same thing as sine over cosine, so go with that. And see if you can do this before you check the solution. Okay, here's the solution. You know, oops, pause. There we go. All right, so we know that tangent is sine over cosine, and that cosines cancel each other out, and you're left with sine t. And that's as simple as I can go. Sometimes as simple as you can go is still pretty complex, but you're trying to simplify as much as possible. We haven't actually gotten into the proof side of things yet. The proof side of things will come in the next section. This is all we're doing in this section is simplifying with rules. Okay, so 1 minus secant squared. We're going to replace that with 1 minus 1 plus tangent squared, because secant squared can be replaced with 1 plus tangent squared t. And then when we simplify that, we get 1 minus 1 minus tangent squared t. The ones cancel out, and I get negative tangent squared t. And that's as far as I can go. Okay. Now, practice 2, we have tangent squared t times cosine squared t plus cosine squared t. All right. Remember that tangent, you could replace tangent squared t with sine squared over cosine squared. Here's the solution. So if I replace tangent squared with sine squared over cosine squared, these cosines cancel out, and I end up with sine squared plus cosine squared, which is the same thing as 1. Example. Oh, I know what happened. Okay. Sorry, when I was recording the original one, it went and they'll go back. All right, so this is a rather complex one. We're going to simplify this as much as we can. So we're going to go tangent squared t minus tangent t minus 6, okay? And then, so this is this part simplified. And then I'm going to go minus 6 right here, plus tangent, because I distributed the minus sign, plus 2 tangent t. And then I'm going to continue to simplify. So So my tangent squared, I can't combine that with anything else. Notice these two tangents cancel each other out, and I'm left with 2 tangent t. And then minus 12. Now, technically, I could break it back out into parentheses, but I want to leave it like this. I don't actually want to simplify further than this. And you notice I used no identities here, okay? This was simplifying with tangents instead of x's. So, all right, here's practice. Okay, now you may use some identities in here. Keep that in mind as you're going about this. You might not. Okay. So here's your solution. Okay. I had to write this one out. So it's sine squared t minus 2 sine x, or 2 times sine t cosine t, plus cosine squared t. Now you know that sine squared plus cosine squared is 1. So I end up with 1 minus 2 sine t cosine t. And I can't actually do any more. And that's it. I will see you tomorrow.